Okay, so this next video is kind of an expansion on my last video, which was about using Pascal's triangle to expand a binomial. In that video, we went over kind of like a general formula, how we would do it, using the letters A and B. But now I'm going to get more into a problem that you would see in like a real math class, on a math test. And so the first step, this is our problem. We have 2x minus 1 to the power of 5. The first step is constructing this. Constructing Pascal's triangle. If you're looking at this triangle and you don't know what's going on, you'll know how I got that. You got to watch my last video. If you do that, this will make a lot more sense. But before we do anything, you would start off with a problem like this. Your sheet would be blank. You wouldn't be given this triangle. Your first step would be you need to construct this triangle until you get to the power that you have up here. So in this case, this is to the power of 5. So we're looking at the 5th power on our pyramid, and that is right here. So what do we do with that layer? Those 1, 5, 10, 10, 5, 1, these tell us the leading coefficients for the expanded version of this right here. So our pyramid tells us that no matter what is in these parentheses, it's going to look like this. We have a 1 here. That means we have 1 times something plus, we have a 5 here, so plus 5 times something. We have a 10 here, so plus 10 times something. Another 10 here, so plus 10 times something. We have a 5 next, so plus 5 times something. And finally, we have a 1 here, so plus 1 times something. Let me make sure the camera's getting all this. Perfect. So now what goes in these spaces right here? Well, in the last video, I used kind of like a general formula of A and B. So A would be anything that goes here, B would be whatever your second term is. So what I'm gonna do, you don't need to do this if you don't want to. I'm just gonna kind of label A and B for myself. So A would just be whatever that first term is. So in this case, it's 2x. B is just the second term. So B is -1. And that formula told us that what we're going to do next is we're going to multiply A and B with each other in each of these blank spaces. Make sure you're putting these in parentheses though. So we have 2x and we have -1. And we're doing this in each one of these boxes. So 2x times -1, 2x times -1. All right, I apologize. I had to write this pretty small. It's a lot going on. If you have to zoom in, you might have to. But all I'm doing is I'm just writing 2x times 1 in each of the boxes, or each of the spaces. Now, I said that we have to raise each of these A and B values to a different power. And it's not just some random power. We're looking at this degree up here, and that tells us the degree of our first A value. So our first A value is this 2x right here. And so our formula tells us that we're going to raise this 2x to the power of 5. And then we're going to count down from there for each of the 2x's that follow. So this is 2x to the power of 5. So this one is going to be the power of 4. This one is going to be the power of 3. This one to the power of 2, power of 1, power of 0. And then we're doing the opposite with our B value. So B, -1, we're starting with our first one, and we're going to raise that to the power of 0. And we're going to count up from there. So this is -1 to the power of 0, -1 to the power of 1, -1 squared, -1 cubed, -1 to the 4th, -1 to the power of 5. And that's the only new part of what we're doing. That's the only part that should be new to you. After this, we're just simplifying. This is stuff you've done before. It's on a larger scale. Sure, there is a lot to simplify here, but you're just simplifying each term one by one. So go piece by piece here, don't try to go too fast. We're starting off by looking at this first part right here. Everything that's attached to that one. And we're just gonna go piece by piece, we're gonna slow down. So, we have a 1, and we have a negative 1 to the power of 0. 1 times anything is just itself. Negative 1 to the 0 is just 1. So this is just a 1 and a 1. So 1 times 1 times 2x to the 5th. So this really just equals 2x to the 5th. Now, let's make a note to ourselves about what 2x to the 5th is. Please be very careful with this. I see a lot of kids, when they're given, this is just a side note, by the way. A lot of kids, when they have 2x to the power 5, they do this. They just write 2x to the power 5. You cannot do that. Please do not do that. What you have to do is distribute this 5 into the parentheses. And you're raising each of the things into the parentheses to that power. So this really equals 2 to the power of 5 times x to the power of 5. To find 2 to the power of 5, you just got to use your calculator. And that would tell you that that equals 32 x to the power of 5. So right here, what we really have is 32 x to the power of 5. And our first little chunk is taken care of. Now let's look at the second chunk right here. We have 5, so plus 5, times 2x to the power of 4. So using that same logic we did there, 2x to the power of 4, that just equals 2 to the power of 4 times x to the power of 4. 2 to the power of 4 just equals 16. So this just equals 5 times 16 x to the 4th times, and then negative 1 to the power of 1, that actually equals negative 1. So this is times negative 1. All right, now we're moving on to this next chunk. We have 10 times 2x cubed times negative 1 squared. So we have plus 10 times, and then 2x to the power of 3 is just 2 to the 3 times x to the 3, which is 8x to the power of 3. And then negative 1 squared is just positive 1, so we don't have to worry about that. Okay, next piece. 10 times 2x squared times negative 1 cubed. So we have plus 10 times, and then 2x squared, that should be 4x squared. Negative 1 cubed is negative 1, so times negative 1. Next, we're at the last two pieces now. 5 times 2x to the power 1 times negative 1 to the power 4. 2x to the power 1 is just 2x, so 5 times 2x. And then negative 1 to the power 4, that's just positive 1, so we don't worry about that. Finally, we have 1 times 2x to the 0 times negative 1 to the power 5. 2x to the power 0, you guys gotta remember, anything to the power 0 just equals 1. So this just equals 1 times negative 1 to the 5th is negative 1. So 1 times 1 times negative 1, that just equals negative 1. So we have a minus 1 there. And now we just have a couple more things to simplify and we'll be done. So 32x to the 5th, that's just 32x to the power 5. 5 times 16x to the 4th times negative 1. So 5 times 16, x to the 4th, that is just 80x to the 4th. 80x to the 4th times negative 1 is just negative 80x to the power 4. And then 10 times 8x cubed, that's just plus 80x to the power 3. Plus 10 times 4x squared is 40x squared. You multiply that by negative 1, you get negative 40x squared. 5 times 2x, that's just plus 10x. And then we still have this minus 1 at the end. And that is our final answer. So we expanded 2x times 1 to the power 5 without using any boxes, any foiling, really not much work at all. We made a drawing, a fun drawing, and then we did a little simplification, and we got it just like that. final answer.